All right. So, as a second example, we have me, Mr. Smith, and Daniela. We leave school at exactly the same time, and we happen to drive exactly east, and she drives exactly south. We don't turn at all. We just keep driving. Okay? We just don't hit anything. It's a miracle. I'm driving at 80 miles per hour, and she's driving at 15 miles per hour. Okay? And my question is, how fast is the distance between them growing after 2 hours? So again, key reason why you should know this is a related rates question is I'm giving you how fast two things are changing. My distance is changing at 80 miles per hour, hers is changing at 15, and I'm asking how fast something else is changing. Okay, so you're given some rates of change, and you're asked to find another rate of change. So again, first step should really be draw a picture of what this looks like. So if we both start at this point here, and I'm driving east, I'm headed out this direction, and she's driving south, she's headed down this direction, and I'm asking for the distance between them. Okay? Now, in the first problem we did, that ladder that I was on wasn't changing. It was always 30 feet. So when I drew my picture, I put a 30 on it because I wasn't changing. But in this case, even though we're going to use the same exact rule, the Pythagorean theorem, all three sides are changing now, which means all three sides have to give variables. Okay? So I'm going to label this one G for Glenn, and this one D for Daniela, and this one down here, I like K. All right? Again, you give them variables because they're all changing. And now, if you keep this in mind here, do I know the rate of change of G? Yeah, we do. It's 80. Do I know the rate of change of D? Yeah. We do. The only thing I want to know is the rate of change of K. So if we get an equation that has all three of them in it, and then we derive it, we're going to have all the rates of change. Well, I know 2 and I want 1. So that's something we can do. Okay? And that's always like a little bit of just forethought that you guys should be doing here. Like if I set this up and derive it, what variables am I going to see? Okay? But again, this shouldn't be any like secret here. We're going to do the Pythagorean theorem, which is that d squared plus g squared is k squared. Okay? We should also know here that if I know d and g, I can also find k at this point. Okay? But we'll worry about that later on. We're going to derive this thing. And by the same exact reasoning of what happened last time, we get a d dt after we derive d squared, okay? And then we get a 2g dg dt, and that has to equal, last time it became a 0 because it was a 900, but now k has a derivative. Everybody okay with that? And now we've got 6 variables in here. But it turns out we know some of them. We just said dg dt is 80. You put that in there. Do we know what g is? What's g? G has to be 160 because we're going to do 80 times 2. Okay? Because I'm doing 80 miles an hour, and the question specifically says, how fast is distance between them growing after 2 hours? I must have gone 160 miles then. So g must be 160. Cool? We also know that Daniela then, since she's doing 15 miles an hour, which is d dt, that she must have gone 30 miles. So we know all those variables. Just plug them in. That's all it is. And we're going to say that's going to be equal to 2. Now I don't know what k is. That's something we have to find. We're not supposed to know dk dt yet. Okay? So the way we're going to find k, again, when you're missing a variable, you don't know how to do it. Go back and read the problem and think, like, what can I use to find it? Okay? A lot of times that comes in the form of an equation, and in this case, we already have the equation right here. If we know d is 160 and d is 30 and g is 160, we can plug them in. So that turns this equation into 30 squared plus 160 squared. And that equals k squared. And because we're never allowed to use a calculator in this class, I know it's terrible. We can do this out here. 30 squared is 900. Plus 160 squared is 25,600. And that has to equal k squared. Okay? And then we're just going to put all this together here. So 900 plus 25,600 is 26,500, and that's k squared, so k must be the square root of that. Okay? And we can simplify that. Like 100 definitely comes out of there, so we can make that 10 root 265. I'm not going to do that right now because it's going to simplify down later on. Okay, so I'm going to leave this the way it is, and I'll simplify it at the end. Everybody good? And that was the last piece that we needed. That's what k is. So this is going to be the square root of 26,500. Cool. And then we're going to solve this out. And it turns out this is coincidental. And not coincidental, it happens because of like the symmetry of the equation here. But we end up getting on this side here, 2 times 15 is 30, and then 30 times 30 ends up being 900. Plus 2 times 80 is 160, and 160 times 160, we just did that, is 25,600. And then over here we have 2 times the square root of 26,500 times dk dt. And if you add those together on the left side, you get 26,500. Okay? So we're going to have 26,500 divided by 2 times the square root of 26,500. And that's what dk dt is. That's how fast the distance between us is growing at that instant in time, after 2 hours exactly. Okay, and we can reduce this so everybody knows here, if you take a number, we'll call it x right now, and divide it by its own square root, that simplifies down into just the square root of x. Okay, by exponent rule. So let's see some weird looks. That's the same thing as x divided by x to the 1/2, and you subtract those exponents. So that really gives you x to the 1/2 power. Okay, you can also just rationalize. It really doesn't matter. But when you take 26,500 and divide it by the square root of 26,500, you're going to get the square root of 26,500. Okay, so this is really going to be the square root of 26,500 divided by 2. Okay, and now at the end here, we're just going to simplify this out here. We can take out a 100, so that's going to really be 10 square root 265 over 2. So that's really going to be 5 square root 265. What are the units on that? Miles per hour, because that's what the other things were measured in. So that's, you can write like this, miles per hour, you can write mph. Cool, but that's what the rate of change of k is with respect to time. Okay.